Hi, myself Alan here. Today I will show you how we make this hydraulic lift or jack.
Now let's explore deeply the concept of Pascal's principle. Let us try to calculate the input and output force of this simple machine for us to better understand this principle. According to Blaise Pascal, a French physicist, in an enclosed container that contains a fluid, the pressure is equally distributed or transmitted in every part of the container. It is just like the idea of chain reaction between these fluid particles, that when one particle is being moved by the applied force or the external force, the other particle or all particles will then be moved and affected by this force. Now remember that the more applied force or external force is being applied, the greater the amount of the output force will then be produced in that enclosed container. This means that pressure 1 or P1 is equal to P2, or pressure 1 is directly proportional to pressure 2. That when you exert a force or the input force, which is the P1 or the pressure 1, it will then be transmitted to all parts of the fluid, which will cause the pressure 2 or an equal force or an equal pressure between these two variables. That is basically what Blaise Pascal thinks, his idea and concept of the Pascal's principle.
Now let's try to calculate the input and output force in this simple machine.
Let's say that a 4 newtons of pressure or an input force is exerted in this machine, where the area 1 of 5 ml syringe is 1.5 cm, the F2 or the output force is the missing one that we're looking for, which has an area of 1.9 cm. First, let us convert the area into square centimeter using the formula of area is equals to pi times radius raised to 2. Pi times 1/2 or 0.5 times 1.5 cm raised to 2 is equals to pi times 0.75 cm raised to 2. Pi is equals to 3.14 times 0.5625 centimeter squared, and the resulting value for area 1 is 1.77 squared centimeter. Now let's look for the area 2 of the syringe, which is 1.9 cm, using the same process as we do on the first area. Area is equals to pi times 1/2 times 1.9 cm raised to 2. Pi times 0.95 cm raised to 2 is equals to 3.14 times 0.9025 centimeter or squared centimeter, and the resulting value for area 2 is 2.83 squared centimeter. Using the formula, P1 is equals to P2. F1 divided by A1 is equals to F2 divided by A2. Let's say that the 4 newtons of input force is exerted in this machine divided by the A1 of 1.77 squared centimeters is equals to F2, the missing one, and divided by A2 of 2.83 squared centimeters. We need first to cross multiply all these variables. 1.77 squared centimeter times F2 is equals to 4 newtons times 2.83 squared centimeter divided by this 1.77 squared centimeter. Divide both sides by 1.77. Cross out the same units. 4n times 2.83 is equals to 11.2 newtons divided by 1.77. Now the resulting value for F2 would be 6.39 newtons. Therefore, 4n input force in this project produces an output force of 6.39 newtons.